Hello, we have finished our special unit on angle relationships, and we are jumping right back into pre-algebra with the Pythagorean theorem. You are going to need some paper or your interactive notebooks to take a couple notes. You also are going to need your workbook because we are going to work some problems together from lesson 7.1. So if you haven't done so, pause the video and go ahead and get those things now. The Pythagorean theorem, there was a mathematician named Pythagoras who found a relationship among right triangles. And so the Pythagorean theorem, you need to write this down, applies only to right triangles. It does not apply to any other type of triangle, just right triangles. And to understand it, you need to understand the parts of a right triangle. The parts of a right triangle, I want you to take a look here. This little square, we've said this many times in class, it means that this is a right angle. The two line segments that join to the right angle are the legs. So we call this leg A and this leg B. This side across from the right angle is called the hypotenuse. And the hypotenuse is the longest side of a right triangle. That is called C. And what Pythagoras realized is that there's a relationship between the measurements of the legs and the measurement of the hypotenuse. And so he found, and that relationship is a squared plus b squared plus c squared. What that means is if you take the length of one of the legs and square it, take the length of the other leg and square it and add them together, you will get the exact same number as if you had taken the hypotenuse, the length of the hypotenuse, and squared it. So he found a relationship that the square of the measurements of these two legs added together is the same as the square of the measurement of the hypotenuse. And we can actually use this relationship to solve problems and to figure things out. So let's go ahead and look at a few problems. One of the things that we can use the Pythagorean theorem to do is to find missing lengths. So let's look at number 4, find the value of x. So we've got a right triangle, there's the right triangle symbol, and we know the lengths of two sides. And as long as we know the lengths of two sides, we can figure out how long the missing length is. So the first thing you need to do, and I need to get my calculator. I'll be right back. Make sure that you have your calculator too. So the first thing we need to do is figure out what is our unknown. Is our unknown a leg or a hypotenuse? Well, this unknown is the hypotenuse. So this is a leg, 7.5 is the length of one leg, and 10 is the length of the other leg. So what we can do is we can put these values into the Pythagorean theorem. Since we know our two legs, that would be 7.5 squared plus 10 squared, and that's going to equal x squared. So again, here's the length of leg A. It really doesn't matter which one you call A and B, but here's the length of one of the legs squared. Here's the length of the other leg squared. And when you add those two numbers together, it equals x squared. So you definitely want to use your calculator for this. So we are going to do 7.5 squared plus 10 squared. 7.5 squared plus 10 squared. and that equals 156.25. So we've got 156.25. That is what x squared is. But we don't want to know what x squared is. We want to know what x is. So we need to square root this, and then we square root that. So we're unsquaring x squared. And if we find the square root of the right side, we have to find the square root of the left side. So the square root of x squared is x. And then we just put into our calculator the square root of 156.25, and that equals 12.5. So the length of x is 12.5 centimeters. So as you can see, we use the Pythagorean theorem to figure out an unknown side length. The main thing you need to figure out is which ones are your legs, which ones are your hypotenuse, and then put them in the correct side. All right, let's look at another one. Let's look at number 5. Number 5, here's another right triangle. We know 10, we know 26, we don't know this. The question is x a leg or a hypotenuse? Well, if you remember, we said the two legs come together at this right angle, so x has to be a leg. So my unknown is a leg. So what we are going to do is 10 is a leg, 26 is our hypotenuse. So let's put it in our formula. Leg squared plus other leg squared equals hypotenuse squared. A squared plus b squared equals c squared. All right, so what we do now is you are going to subtract 10 squared from each side. Okay, that cancels out. So we've got x squared equals, and let's take our calculator and let's do 26 squared minus 10 squared. 26 squared minus 10 squared, and that equals 576. All right, but x squared is 576. I don't want to know what x squared is. I want to know what x is. So I have to unsquare x squared. And if I unsquare the left side of the equation, I have to unsquare the right side of the equation. So x equals, so let's go back to our calculator. And we are going to find the square root of 576, and that equals 24. So the length of the leg, x, is 24 centimeters. All right, so we looked at 4 and 5, and both of these are finding unknown side lengths. So we can use the Pythagorean theorem to find unknown side lengths. 7 through 10 are our figures are a little more complicated than the other ones. Let's look at 10, but we can use the Pythagorean theorem still to figure out unknown side lengths. So let's look at number 10, because I think 10 is pretty tricky. There's a couple of things when I'm looking at this. I see one right triangle, this outside, the outer is a right triangle. So we've got a large right triangle. I see a small right triangle here. And then I see a third triangle, but this one is not a right triangle. But I can tell because it's got these two things that these side lengths are the same. And so it is an isosceles triangle because it has two side lengths that are the same length. So let's see what this is asking us to do. It says, calculate each unknown side length, round your answer to the nearest tenth. Okay, so I've got two unknown side lengths. I don't know what x is, and I don't know what y is. And I need to start with what I know. I do know that this is 11 and this is 7. I can also tell that these are a part of the small right triangle. And so I've got two of the lengths, and I can use the Pythagorean theorem to figure out what this length is. Well, once I know this length, because this length is the same thing, x is whatever this is. So I can find x that way. And then once I know what x is, I know what the long length is, well, the long leg and the shorter leg, and then I need the hypotenuse. Okay, so let's start with our small one. That's the only place we can start. Our unknown is this one. What is our unknown? Well, it is the hypotenuse. We know the legs. So I am going to put 7 squared plus 11 squared. Those are the two legs. That equals, I'm going to just put c squared for that one. So get our calculator out. And we can be a little bit more efficient. I just want to point this out. I do know that I don't want to know what c squared is, so I can go ahead and let me just go ahead and unsquare this, because that will take care of this, and then I can just put all of this in my calculator instead of breaking it into two parts. So we are going to take our calculator and we are going to put our square root in there and then do 7 squared plus 11 squared and enter. Whoops. All right, I need to turn that. It gave me math print and I needed it in classic. So again, remember this button down here, whoops, this button. If you get it in math print but want it in classic form, you can toggle between that. Okay, so the square root of 170, which is 13.0384. The directions do say to round to the nearest tenth if you need to. We've got a 0 in a tenths place, so this is going to round to 13.0 because a 3 next to it says so. So the answer is 13.0. I go ahead and write 13.0 because that tells me that we are, that lets me know that to the 10th, that I rounded to the 10th actually. All right, so I'm gonna write 13.0. And so X, let me write my answer out here, is 13.0. And so this is 13, right? I kind of squished my work. So now I need to find what y is. Well, y is the hypotenuse of this giant, of the big right triangle. I know this leg is 11. Now this leg I know is 13 and 7. So this leg is 20. So we've got a leg that's 11, a leg that's 20, and a hypotenuse that we don't know. So let's put that in our Pythagorean theorem. Leg is 11. Square it, plus 20 squared. So those are the two legs. That's going to equal c squared. But again, I'm going to do this right now because I know I don't want c squared. I'm going to have to find the square root. And I'm just doing that because it's a little more efficient. So let's put that in our calculator. We've got square root of 11 squared plus 20 squared. That equals 22.8254. Rounding to the nearest tenth would be 22.8. So that means that y equals 22.8. And they're side lengths of a figure, so it's just linear inches. So there's your answer for 10, x and y. So 7 through 10, it is also finding unknown side lengths. It's just that our figures are a little bit more complicated. All right, another thing that we can do with our Pythagorean theorem is if we've got all 3 side lengths, figuring out whether or not this is a right triangle. Now we're not going to do this all together, but I'm going to get you started on field A. But 11 says, Fritz knows 2 triangular fields, determine which field is a right triangle. So we can put these lengths in the Pythagorean theorem and then test it and see if it works. All right, looking at this, this would seem to be this is a leg. this is a leg, and then this is the longest side, so that would be a hypotenuse. So we are going to put 36 squared plus 48 squared equals 60 squared. So then you just use your calculator and figure out if they end up, if this is equal, if 36 squared plus 48 squared is equal to 60 squared, then this is a right triangle. If it is not, or if it is not the same, then it is not a right triangle. So you're going to figure that out for both of these to figure out which one is a right triangle, or maybe both of them are, or none of them. All right, so that's 11. Now the rest of this assignment are word problems, and to be quite honest, they're really pretty straightforward, but there are a lot of them. So we're going to go page by page. We're going to do, I think, one, maybe two together, and I'm going to tell you how many I want you to do on each page. So on page 3, you've got 3 problems, 12, 13, and 14. I want you to pick 2 of those. So that's on page 3, pick 2. Page 4, I want you to pick one of them. There's 15, 16, and 17. I want you to pick one, but we are going to do 16 together. So you can't pick 16. You're going to pick one of 15 or 17. All right, so let's do 16 together. It says a taut cable connects 2 cable car stations A and B, which are positioned 50 meters and 20 meters above the ground. The horizontal distance between the stations is 1/2 kilometer. Find the length of the cable. This one is pretty tricky because if you look at this drawing, this is not a right triangle. This is actually, it looks to me to be a trapezoid. But we have enough to be able to use the Pythagorean theorem to figure this out. The other thing is this is given in meters, these 2 lengths, but this length is given in kilometers, and no bueno. So we need to figure out how many meters are in 1/2 kilometer. Well, a kilo means 1,000, so a kilometer is 1,000 meters. 1/2 of 1,000 meters would be 500. So I'm going to mark through that, and let's write 500 meters. Okay, so this dotted line is the ground. Then we've got 20 meters up and then 50 meters up. And so what I'm going to do is draw a line from here straight across, and then I will have a right triangle. I'm going to use my, let's see if I can do this fairly. All right, it is not very straight. Clearly not, that's terrible. All right, let's try this again. Okay. All right, so this is our right triangle. All right, this length is the same as on the ground. So this is 500 meters. Now this length right here is not perfect, but this is 20 meters up. So I raised this 20 meters, so that means this would be 30 meters. This is definitely not drawn to scale, and I definitely did not draw a very well drawn straight line, but you get the idea. If I were making this into a right triangle, we have 30 meters by 500 meters by unknown. That's our unknown. Our unknown, this is a leg, this is a leg. Our unknown is the hypotenuse. So we are going to put that in there in the Pythagorean theorem. So one of the legs is 30 squared plus the other leg is 500 squared, and that equals our unknown squared. All right, so I don't want to know what x squared is. I want to know what x is, so we're going to square root it. And let's square root this. So we have x equals. All right, get the calculator. So we are going to do the square root of 30 squared plus 500 squared, and that equals 500.8999. We're rounding to the nearest tenth. The 8 is in the tenths place, and it's going to round up to a 9. So it is about 500.9 meters. All right, so on this page, you need to pick one of the other two to do, so either 15 or 17. All right, on page 5, you have 18 or 19. You pick either one, pick one of those. On page 6, we've got 20 and 21. I want you to pick one there. Page 26, pick one. (27), I want you to do 22A. Omit B and omit 23. So we're going to do 22A. Oops, sorry about that. On page 8, I want you to omit 24, but do 25. Okay? So that covers it. This is a long assignment. So this week, the only thing that you're going to need to do is do your quiz on our angle relationships, and then do this 7.1. We're not going to have a third assignment. So have a great day. Remember, I have office hours from 1 to 3. So you can email me, you can call me, text me, FaceTime me. But if you're working your math and you're struggling on something, please give me a call, because I do want to help you. All right, you guys, have a great day. Talk to you later. Bye.